Hi everyone, this is Yukabuka and welcome to my home on YouTube. In this video we will resume where we left off in the last one. This is the second video in a series about kobjects in the Linux kernel. A quick note about something I had mentioned in the last video. Something occurred to me shortly after making it, that my idea about how k-sets are represented might be a bit mistaken. I had mentioned that I didn't quite see how a k-object could be a part of a k-set, but it did. When I thought about it, the description of a k-set over here did mention that k-sets contain their own objects, but you can safely ignore that implementation detail. So according to a description of k-sets, k-set is essentially a container type for a collection of k-objects. However, after reading this line here, we can infer that this k-object here is not one of the constituent k-objects present in the k-set. This k-object here is probably the one being referenced in this line. K-objects contain their own k-objects, but you can safely ignore that implementation detail. Okay, so let's look at the next section, and that is embedding k-objects. Alright, it is rare for kernel code to create a standalone k-object, with one major exception explained below. Instead, k-objects are used to control access to a larger domain-specific object. To this end, k-objects will be found embedded in other structures. If you are thinking of things in object-oriented terms, k-objects can be seen as a top-level abstract class from which other classes have been derived. A k-object implements a set of capabilities which are not useful by themselves, but which are nice to have in other objects. The C language does not allow for the direct expression of inheritance, so other techniques such as structure embedding must be used. Okay, so far it makes sense. The idea is that k-objects are not used on their own. You need to embed a k-object within other structures for it to be useful. As inheritance isn't present in C, you use structure embedding, and that is something that reminds me of the programming language Golang, where you don't have inheritance either, but you use structure embedding to sort of have a similar effect. Okay, as an aside, for those familiar with kernel linked list implementation, this is analogous as to how list head structures are rarely useful on their own, but are invariably found embedded in larger objects. Sounds good? Okay. So for example, the UIO code in drivers uio.c has a structure that defines the memory region associated with a UIO device. Okay, so let's have a quick look if we have a UIO map. We don't have a UIO map, and that's probably because the ARM kernel that I have has not compiled support for UIO. So let's take a look at Elixir and see if UIO map. See if the latest version of the kernel has the same structure for UIO map, and yes, it does. So it has a k-object and it has a pointer to UIO mem. Sounds good. I'm not quite sure what a UIO device is. UIO device. It's a user space driver. Interesting. The concept of a user space driver has appeared before. It does not completely eliminate the need for kernel space code. Okay, so without diving into all the details, it's effectively a way to write Linux kernel drivers in user space, though there is some bit of code in the kernel. And the bit of code that is in the kernel is probably the UIO infrastructure, which allows for writing user space drivers. Yeah, that's my guess. Okay, let's get back to the original documentation. If you have a struct UIO map structure, finding its embedded kobject is just a matter of using the kobj member. Code that works with kobjects will often have the opposite problem, however. Given a struct kobject pointer, what is the pointer to the containing structure? Right. You must avoid tricks such as assuming the kobject is at the beginning of the structure, and instead use container of macro found in Linux kernel.h. Right, sounds good. So container of is a very nice macro that I encountered while looking at the list implementation used in the Linux kernel. You can find it inside include linux llist.h or include linux list.h within the kernel source, and you can see how the implementation makes use of container of. Container of is a very interesting wrapper around the offset of macro that C provides, the C compiler, or I'm not sure what provides offset of. Is it? So offset of is provided by stddef.h, and effectively, given a struct type and the name of a member, it will give you the offset in the struct at which member is present. Container of is a macro that builds on top of offset of, and effectively it gives you a pointer to the member of the object pointed to by PTR. So just to clarify this, we have an object which is pointed to by PTR, and the object is of type and has a member. This will return, container of will return a pointer of, I'm curious though, because I think type is for the member, right? That's what this seems to suggest. So what we're doing here is we have member being typecasted to 0, okay, and you have an mptr defined which points to PTR, right? So let's see. This seems to suggest that both PTR and member are of type, but I am not too sure about that. I wonder if we have an example I can refer to. Container of. Okay, and I will look at the references of this. Yeah, just a few of them should be enough. we see that over here it's being used as container of delayed work, and delayed work is a pointer of type struct delayed work. And the second argument is struct mwi private. And if you look at that, we can see that it's a struct type. And does delayed work have an instance of struct mwi? No, it does not. How about this struct here? Does it have an instance of struct delayed work inside it? Let's see. Where is that? Ah, yes. So there is an instance of delayed work over here inside struct mwi private, and the name of the item is different though. It's a DFSCAC. Yes, so this is the one we are looking for, the one right under my cursor, and that is the one we are getting a pointer to. Okay, so essentially what the format of container of means is that the first argument refers to the type of the member within the struct. The second argument refers to the struct itself, and the third argument refers to the name of the member, right? So if you look at this, it's container of pointer, type, and member. So pointer is let's see. So pointer is a pointer, well, to the delayed work inside struct mwi private, right? Pointer is a pointer to the embedded kobject. Okay, so yeah, so pointer would be the pointer of delayed work inside struct mwi private with the member name dfscac work, and at that point you get what is returned is a pointer to the containing structure. Okay, that sounds good. So effectively what you have here is you have a pointer to the embedded kobject, you have type is the type of the containing structure, and member is the name of the structure field which pointer points to. Sure, that sounds good. That makes sense. Let me just quickly write this down so that we get it. gis.github.com. I hope I can make it an anonymous post. So what we have here is struct container struct, and then inside it we can have an item, let's say kobject, kobj, and then an int val1, a char star ptr2, and some values there, right? And let's say that we have a pointer to kobject somehow. kobject star ptr, right? This refers to, also let's say we have a container struct cs. So this ptr points to the kobject inside cs, right? So let's also have a struct container struct star csptr. So what they are saying is that you can get csptr given ptr as follows: container of kobj struct container struct it wouldn't be kobj, my bad, it's ptr, and over here the member name is kobj, right? So at this point csptr would be equal to &cs. Cool. I hope this clears things up. Let's have a quick look at how this is implemented though. You have a const type of type of 0. So you're typecasting that type onto 0. Sure. So in this case, if you typecast this onto 0, then the offset of the member will be given by arrow member, right? So this type here, so yeah, that's what it seems like, right? Right, so type of is used to dynamically give you the type of that member. Sounds good. And then mptr is equal to ptr. Okay. Right, so this is effectively just a typecast. I imagine that you could replace this line with void star underscore underscore mptr equals ptr, and it would still be more or less okay. Right. So the next thing they do is they take underscore underscore mptr and subtract the offset of, in this case, dfs calc work from the beginning of struct mwifx private, and then they typecast it to type and they return that. That's it. Cool. The only thing is, type of is something that is very new to me. I don't see why a void star isn't used. Perhaps using type of gives us the ability to perform additional compiler checks. That's my guess anyway. Okay. Right, so in this case the return value of the container of is a pointer to the corresponding container type. For example, kp points to the struct kobject embedded within a struct UIO map and could be converted to a pointer to the containing UIO's map structure. Yep, sure, that sounds good. It's exactly as we saw in the example. So for convenience, programmers often define a simple macro for backcasting kobject pointers to its containing type, and this is what happens in uio.c. So you have a toMap of map returning the kobject, returning the taking in a pointer to the kobject and returning a pointer to struct uio map. Okay. Where yeah, this makes sense, so I'm just going to skip over it. Let's look at the next section as well, because this section did not have a lot of kobject specific information. We'll look at the initialization of kobjects. Code which creates a kobject must, of course, initialize that object. Some of the internal fields are set up with a mandatory call to kobject init. And the prototype is as follows. Let's take a quick look at kobject init. Okay, so there's quite a, let me just real quick. Okay, it seems to be a really small function, isn't it? The function will be properly the function will properly initialize a kobject such that it can then be passed to the kobject add call. After this function is called, the kobject must be cleaned up by a call to kobject put, not by a call to kfree directly, to ensure that all the memory is cleaned up properly. Interesting. So you initialize a kobject by using kobject init, and then you start using the kobject by calling kobject add, and you stop using it by calling kobject put. They seem to emphasize on the fact that you should not call kfree on the kobject directly, and this is probably because kobject put decreases a reference counter inside it and then frees the object. I'm not sure, but that is a possible scenario. Let's take a look. So they check if kobject is a valid pointer. They check if ktype is a valid pointer. If they're null, then that would make no sense. So that's essentially what these checks are doing. And if kobject arrow state initialized, I didn't know that. I don't recall seeing such a state initialized. Oh, so there is a bit field inside struct kobject called state initialized. And what they're doing here is that if it's already initialized, then don't do it again, just dump the stack. So yeah, okay. You have a kobject init internal of kobject. Okay, which seems to be setting different values, initializing different values. So we can see here that the kref part, that is the reference counting part inside the kobject, is initialized using kref init. The list part inside the kobject is initialized using init list head, and then the bit fields are set to 0 except state initialized, which is set to 1 at this point. After that, the ktype is also set to whatever value is passed in, and that's pretty much it. Okay, sounds good. There is also an error. Okay, that sounds good. So in cases where kobject and ktype are null pointers, you would just print an error and dump the stack. Sounds good. Okay, now the ktype is required for an object to be created properly, as every kobject must have an associated kobject type. Yes, we saw how it's being assigned. After calling kobject init, to register the kobject with sysfs, the function kobject add must be called. Right. So that seems to be the reason why you need to call kobject add. It essentially registers the kobject with the sysfs file system. Okay. So the function kobject add must be called, and this sets up the parent of the kobject and the name of the kobject properly. I think it's better if we look at the source first and then read this documentation. So kobject add. Okay, so in this case we have, let's just real quick go through this documentation. The kobject name is set and added to the kobject hierarchy in this function. If at parent is set, then parent of the kobject will be set to it. If parent is null, then the parent of the kobject will be set to the kobject associated with the kset assigned to this object. That is interesting. So it turns out that you probably won't have a whole lot of kobjects for which parent is set to null. I am assuming that if there is a kobject associated with sysfs, then that is the only one for which the parent is set to null. I'm not sure of that though, because this statement says that if the parent pointer passed here is null, then the kobject's parent will be set to the ksets will be set to the parent. Then the parent of the kobject will be set to the kobject associated with the kset assigned to this object. Got it. So earlier, while looking at a kset, we saw that there was a kobject inside it. So if you're calling kobject add on a kobject which is part of that set and has a parent set to null, then the parent will be set to the kobject inside the kset. Yes, that seems to be right. If no kset is assigned to the object, then the kobject will be located in the root of the sysfs tree. Okay, interesting. So, in that case, will it be null? I'm not sure. If this function returns an error, kobject put must be called to properly clean up the memory associated with the object. Right. Under no instance should the kobject that is passed to this function be directly freed with a call to kfree. This can leak memory. So this seems to be something they mention over and over again. They mention this quite a few times, that kfree should not be called on a kobject. You should only call kobject put. Note, no add uEvent will be called with this call. The caller should set up all of the necessary sysfs files for the object and then call uEvent object with the uEvent_add parameter to ensure that user space is properly notified of this kobject's creation. I'm not sure what this refers to. Yeah, so it says that no add uEvent will be created with this call, but I'm not sure what they are referring to by a uEvent. I recall reading about uEvents in the context of hot plugging, but I'm not sure if that is applicable here. If user space is properly notified of this kobject's creation. Yeah, I'm not too sure about that. Yeah, we can get back to that at some point in time, but yeah. What it says that the caller should set up all of the necessary sysfs files for the object and then call this with this parameter. I see. Okay, now I understand. So apparently there is some way for the kernel to provide notifications to user space, and that mechanism is referred to as uEvent, and just calling kobject_add does not provide user space with that notification. However, after doing kobject_add, if you do a kobject uEvent with the parameter uEvent_add, that is when user space will receive a notification that a kobject has been added. So I would assume that it's a common practice for kobject users to first call kobject init, then kobject add, and then call kobject uEvent. Okay, sounds good. So as we can see here, this is a periodic function that receives a non-constant number of a variable number of arguments. We can see that there's a format and probably there are arguments after this which are accessed using va list or va_arg as shown over here. So it checks if kobject is null, if so returns inval. It checks if it's not initialized, then it's an error. And then for each of these arguments, it calls kobject add varg. I'm not sure what that does. It is taking each argument and doing something with that. We will need to look at what that does. And then it returns the ritval. So essentially, we need to find out what this function is doing with the arguments, right? As it is in black, it shows that source inside does not recognize this function for some reason. Let's see. Oh, no luck. So let's just go back to Elixir and go here. And yes, we found the function. What is this doing? It says static __ printf. I'm not sure why it would use what that notation refers to. Attribute format printf scanf. Many functions have no effects except their return value, and the return values depends on the parameter such a function is subject to common sub-expression. I see. So I guess this is a way of telling the compiler that this is a function that is similar to printf in terms of the arguments that it accepts, so that the compiler can perform optimizations. Interesting. I'm not sure what these arguments are. There are two arguments, A and B. Oh, so those would be the arguments. One would be the format string and the second one would be the va_args, I guess. Okay, interesting. So from what I quickly gained by glancing through this, it's for compiler optimization. Okay, so in this case we have the vargs, and then it again calls another function. It sets its parent over here to the parent that is being passed, and it calls add internal. I'll have a quick look at setName vargs because I have a feeling that kobject add internal is the main function. So let's have a really quick look at setName vargs. Inside setName vargs, you have a kobject, a format, and a vargs. There are some sanity checks here, and then it's effectively doing a kvfprintf, or that's what it seems like. And it's doing, okay, they have an interesting comment here, a replace of the slash with an exclamation, and then they are freeing kobj name, and they are setting kobj arrow name to s. Interesting. So what they're doing is the kobj arrow name pointer is being freed. So out of curiosity, right, so where was this allocated? Was this allocated inside name? Because I really don't remember where memory was allocated for kobject.name. So let's have a quick look at kobject init. And inside this, there is an init internal, which doesn't do much. Interesting. What about kobject add? Because that's how we got here. Interesting. That is indeed a bit strange, isn't it? Are they relying on the fact that kobj-name is a null string or an allocated buffer? That kind of seems to be the case here. Okay, I'll come back to that later. In any case, kobj-name is being set to this newly created vprintf buffer. Yeah. Okay, so we've done with that, and now we can come back here to the function kobject add internal. Okay, kobject add internal is a slightly bigger function, and what we have here is the function receives a pointer to kobject. It performs some validity checks to make sure that the name has been populated, and parent is called with kobject get of parent. Okay, so I'm assuming this somehow returns a pointer to, but why would you, I think it increments the reference as well, right? So kobject get is defined here as a function, and we can see that it's effectively incrementing the reference here before returning the parent kobject. So the kobject passed into the kobject get function is the one that gets its reference counter incremented. So in this case, the reference count of kobject arrow parent is the one that gets incremented, and that makes sense because the rest of the code might be using parent, and because of that you don't want that kobject to be freed elsewhere in the kernel. You want to, and as a result you want to increment the reference count by 1. In this case, if kobject dash kset, if kobject arrow kset, then so we have a comment here that says if kset is set, use it as a parent if we do not already have one. Okay, that makes sense. Yes. Use it as a parent? That's a bit strange. Yeah, so in this case, this comment is a bit wrong because the kset is not being made as the parent. You use the kobject inside the kset as the parent. So you do parent is equal to kobject get of kobject arrow kset arrow kobject. Kobject arrow kset arrow kobject. Yes, that makes sense. And it's I like how they do a kobject get directly on the object that they want to work on, right? That's kind of interesting, because they could have done this in 2 steps where they first get kobject arrow kset arrow kobject and then do a kobject get. But I believe there might have been a race condition there if you had split this into 2 lines. but this kind of use hopefully doesn't cause a race condition, and that's interesting. Kobject kset join. So that's the function that's used to add a kobject into a kset. And kobject arrow parent is equal to parent. Okay, that sounds good. I wonder why you would do a kobject kset join. Because it's already part of the kset, isn't it? I'm not sure why that is done. Right, so what's happening here is we have a kobject, we check if it is already part of a kset, and if that is the case, it returns. Okay, and it increments the reference counter on the kset. It acquires a spin lock on the list, on the kset list. It adds the kobject onto the ksets list, and it unlocks the spin lock. Fair enough. However, you are incrementing the kset counter here. Where is that being decremented? I don't think list add tail would do that. Yeah, see, list add tail doesn't do anything of that sort. That is interesting, because it is incrementing the reference count by 1 for kset. Why isn't it decrementing it? Also, it checks if the kset has already been set, which means there is some code path, or there may be a code path where kobject already has a where kobject does not have a kset set, and this function is being called. So the question is can this code be executed without kset being set? No, it can't. So I'm curious about why this call exists at all. You enter this function only if kset is set. So what's the point in having this again? I'm not sure at all. Interesting. Let's look at the rest of the code. We have a PR debug, which says that there is a kobject, a parent, a set. Okay, that's just an informational message being written out. There is a create directory of kobject. I assume this ends up creating a directory inside /sys. And if there is error, there is a bunch of cleanup, and if not, then you set the state in sysfs to 1, and then you return the error. That sounds good. A quick look at create dir. You have a struct kobject star kobj. There is a function to create a directory ns. There is a function to populate the directory, remove the directory, increment the pointer, and so on. Interesting. So this seems to be the location where a directory is created within sysfs to correspond to this kobj. Let's take a quick look. So this is where I will be pausing the video and continuing in the next one. We will continue to go down the rabbit hole because it is hard to understand all the details without going through each and every function that is being called. And as the effect of reading code is something that compounds over time, as we continue reading code, we will be going down the rabbit hole fewer and fewer times. But as we start off with kobject, we will need to do this. So just a quick recap of where in the source we are currently, so that we can pick up really fast. We have a create directory function which gets called from the kobject add internal function, and the kobject add internal function gets called from kobject add varg. The kobject add varg is in turn called from kobject add, and that is where in the documentation we were at, right? So in the next video we will read through this once more, this paragraph, and we will continue to dive back into the rabbit hole here. That's it for now. Hope you enjoyed the video. If you like, please hit like and click subscribe. See you later.